Welcome to AgVision. There are 3 Ds that can quickly cripple any farm business: death, divorce, and disability. On the show today, Lane Fraze tackles the awkward question, when you die, does your family know what to do? Also, it's been more than 12 years since Canadian farmers first began growing genetically modified crops. The first wave of biotechnology has been characterized by herbicide tolerance and insect protection. Stacked offerings with more than one genetic trait present in a crop are expected to develop and improve. But where do we go from here? A look now at the next wave of agricultural biotechnology. In 2008, Canada was ranked the 4th largest producer of biotech crops in the world, according to the International Service for the Acquisition of Agri-Biotech Applications, with 17 million acres planted to genetically modified corn, canola, and soybeans. Only the United States, Argentina, and Brazil grow more biotech crops. Suffice to say, this technology has secured a solid footing in the present and future of Canadian agriculture. So what's next? Dr. David Dennis says the next wave of biotech will include weatherproofing crops. Dennis is the co-founder and president of Performance Plants Incorporated, a Canadian-based biotechnology company that has developed traits to boost yields and drought tolerance. Dennis believes biotech in the near future will be about tweaking individual traits to help a crop cope with environmental stresses such as drought, heat, cold, or frost. The trick will be to accomplish all of this and continue to improve yields to meet growing demands.
Yes, the next wave is going to be quite different from the first wave. The first wave basically was putting mainly bacterial genes into plants to give them insect resistance or herbicide resistance. What we're doing now is modifying the plant itself. So the plant has got new properties. Now we've been doing this for 10,000 years. So our sort of objective is to modify a single gene in the plant and produce a plant that you want. So make it heat resistant or cold resistant or drought resistant by modifying a single gene.
Because of the recent rise in commodity prices, it's since fallen back. People are looking at this as an opportunity because of this huge demand that we're going to have for agricultural production.
While both Surgener and Dennis view biotechnology as part of a solution to meet a growing demand for food, they see the next wave of biotech traits extending well beyond agronomic advances. They believe this technology will provide solutions to various environmental challenges, including biofuels production.
If you look at the major seed companies, many of them are promising that by the year 2030 we will double the yield from crops that we currently grow, like corn, wheat, soybeans, etc. And in so doing, that's a plus towards bioenergy. But more importantly, we have a number of crops like miscanthus. I believe in Canada, hemp is a good alternative, switchgrass, where we can incorporate certain traits that will allow better digestibility for cellulosic ethanol as an example. So yeah, I see these traits and technology in those areas as well.
Climate change is a real thing, and people talk about climate warming and global temperatures going up and sea levels going up. I think the biggest problem we're going to have with climate change is variable climates. So you'll never know what you're going to need. So we're going to have to make plants which are able to resist quite a lot of different stresses.
And we're already starting to see crops specifically designed with omega-3 soybeans as an example. So with output traits that create higher value to a consumer.
The big question is, when will farmers start to see the next wave of biotechnology?
One of the problems with the new biotechnology is that it's much more difficult to actually show how it works. If you've got to make plants insect resistant or herbicide resistant, well, you spray your plants with herbicide and you know how well your gene is working. If you're trying to make them more water use efficient, then that's a much more difficult thing to demonstrate. Is in going from a gene to a plant that you can actually sell to farmers is a long time, so you're looking at something like 7 to 10 years. Some of the technologies that we're involved with, and I know other companies involved with, should be around in the market in 3 to 4 years.
Coming up next, Gord Surgener provides more specifics about the next wave of agricultural biotechnology. Across Canada, you're watching AgVision.